We'll be talking about guns. No. You ready? Okay. All right, so since we're all running over, can everybody hear me okay? Is this good? Hello? Test, test. Okay, so some of you probably have seen some of my stuff before, data recovery, diagnostics, repairs, things like that. So, so basically that's what this talk is about, is actually doing the pre-stuff to any of the other talks that I've done. Basically, I'm going to be looking at hard drives and trying to do the diagnostic component so that you can try to figure out what's wrong with it before. Later on, all my other talks, which is kind of what this next thing is, all the other talks I've done have been all about repairing the drive, but I get tons of emails about what's wrong with my drive before that actually happens. So, and a lot of the assumptions are wrong. I mean, I get some weird things like, I've got a Maxtor 160 gig hard drive, can I pull the platters out and put them in a Western Digital 160 gig hard drive and recover my data, things like that. So, so basically, I kind of want to take a step back and just try to say, what can we do to repair hard drives? You know, look at the diagnostic component before we actually get to the repair component. I've got some repair stuff in here. This is a little different than some of my other stuff because this is basically a conglomeration of the thousands of steps you could take to actually look at a hard drive to figure out what's wrong with it. And it's a little different than what most people would actually think in some cases. So that's kind of the point of this. And then the idea is, too, is that eventually at some point in time, if you just watch all the videos, because I've got like 50 hours of stuff out there on how to do data recovery and repair stuff. I run a data recovery company. I've been running it for 10 years now. Pretty much have everything that there is. I also teach the SANS data recovery class, which I wrote, and do things for like FBI, CIA, things like that. So, so basically that's my job, is to try to get drives running again that are damaged if it's possible. And then I got a lot of ugly text, but I got a lot of pictures and videos from things I've collected over the years of either weird problems or things that happen, and I'm going to just, you know, call things that suck. This is the kind of the point of the breakdown of the steps that I'm looking at, because this is where people are at where they go, hey, I've got a problem with my hard drive, but I don't know where to start and when to stop. Because some people go way too far. I mean, they get into a spot where they have ripped out the platters and done something else, and they really need the data off that drive, but they've already gone too far. And so I'm also going to try to be bringing up where to stop and kind of look at that position and try to figure out how detrimental what you're about to do is to the drive. Because some people just jump right in and be like, oh, I need to replace the heads, and try to rip the heads off before they even know if it's actually the heads that are wrong or that there's something wrong with. So I'm going to try to break those things down. Some things are not going to be quite as obvious as this, okay? So it's pretty obvious when you've got a burnt board most of the time. Most people are pretty clear on what that kind of problem is going to be. They may not be clear on how to fix it. In some cases, this might actually be hidden because the board might be upside down. So before we jump into this, I'm going to kind of do like just a quick 10-minute kind of education, some previous stuff I've done, and some ideas about the hard drive so that you can build on it as we go through the diagnostics so you can kind of understand what's going on. So this is the first thing. Don't be anxious to swap parts. That's the last thing anybody should do. You really have to know whether or not you're able to read a byte off that drive or know what kind of data that you're looking at. A lot of people will be, hey, my drive doesn't mount. What am I going to do? And so they think right away, oh, well, then I've got to start swapping boards, or I've got to start swapping heads and things like that. In a lot of cases, you can actually do more damage, even just by swapping a board. The boards actually know things like the voltage of some of the chips that are actually mounted on the head assemblies. And if you just do a board swap without thinking about it or knowing what's going on, you can actually apply a different voltage to the internal mechanism that blows the chip, which then causes you to have to do a head replacement, which you normally would not have had to do. So we're going to at least take a little bit of a step back before you get there, so don't cause more suck. So real quick, this is just kind of the 5 basic fundamentals of when you're doing data recovery, what your steps are. So physically, you would normally be looking at diagnostics. Then if you can't, because you're going to kind of jump to this step, which is imaging. So a lot of people think of imaging, oh, I'm just copying the drive. There's a lot more to it than that. There's a lot more to, I just have a piece of software and I copied a drive. This is actually the fundamental stage, is imaging for every data recovery company. And these 3 are linked together. So you start your diagnostics by trying to do imaging, finding out whether or not certain things are wrong. And there are certain pieces of equipment which will actually just give you answers right up front. but they're thousands and thousands of dollars. So we're going to try to take the cheap route. And then you would go through this process in a circle. Repair the hard drive, image it, try to go through this process. The whole point is to forget about files. We're not looking at files. Stop thinking about drives and files. The drive physically has all these things that are going on inside of it first, before you're actually dealing with the files. And it doesn't care about your files. It doesn't know anything about your files or your file structure or how your OS laid out clusters or whatever you chose for your inode settings or something along those lines. So forget about files when you're trying to do data recovery. Let's take a step back and let's start talking about sectors and LBA blocks and how we're actually going to copy those sectors off of the drive and what we're going to do with them. And so this would kind of be y'all's response. Well, look, I plugged the drive in and I try to copy it. Dude, this doesn't work, or I would have done that. So let's try to look at that item itself. So these are going to be the things to suck that we're going to get out of the way. So we're just going to remove these things from the picture so that you at least get a better idea of what we're looking at. So imaging tools, diagnostic tools, vendor tools, things like that. Software repairs like check disk and things, horrible things. Freezing the drive, smart, and USB. So what is wrong with these? Anybody have a good idea what's wrong with these? Well, besides you pay for them, I mean, some good tools you pay for, but I'm just saying, as a whole, this is typically when people go, oh, I'm going to image or I'm going to do a backup, this is the kind of stuff that they're looking at. Well, these kind of things, typically, any time that you're dealing with bad sectors or a bad hard drive, they are worthless. They completely fail. I mean, how many people have tried to use Ghost before, and you read a bad sector, and what happens? Just bombs, crashes, or hangs, and never comes back. Even if you've tried to use things like FTK Imager or something like that, Forensics Toolkit's Imager, what happens when you get to a bad sector? It just sits there and chunks on it, or you get an image that has just zeros in it. So you don't have anything. That doesn't mean you couldn't copy it. That doesn't mean you could not get those sectors back. It just meant that trying to do a sequential image with a dumb piece of software that doesn't know how to control the drive can't do the job. And that's where our problem stops. So this is the kind of stuff that just sucks. And so, stop thinking in those terms. And so if you want to deal with damn piece of fail. All right, so if you want to deal with a little bit more robust software, now I'm not going to kid you that when you're actually dealing with hardware errors and things like that, hardware does do the best job. It's not that there isn't a software solution. It's just software typically is going to cause more problems from a time standpoint. It's going to take a lot longer to do it, and software can't control power. So that's the biggest problem. Like if a drive hangs, sometimes like a head will actually be reading data. It will hit a spot, and after that spot, it will never return a result again until it's been powered off and powered back on again. All those other imaging products that you've been dealing with to image sectors and do things are not capable of picking back up after a failure, and they're not capable of turning the power off. And so they're always sequential. Almost all of them do from the lowest LBA, the lowest sector, to the end of the drive, and they don't know how to do anything else. They don't know how to just randomly start at a new location. So that's where some of your other problems come in. But since we're looking at kind of the cheap, free, easy kind of thing, all of these typically at the top, they're not all free, but like MyRescue on Linux and DD Rescue, and there's two different versions of DD Rescue. There's an underscore and one without an underscore. They actually are fantastic at recovering from damaged sectors or dealing with something. But for people who like to click on things, Media Tools Pro is about $300. It can do what's called a reverse image. And that's kind of the trick with some of these, is that they can do reverse imaging. And then there's this free tool, the Ultimate Boot CD, which has a lot of things pre-prepared for you. It's got a bunch of these other things already on it, with the exception of the Linux tools and stuff, because it's like a DOS boot floppy kind of thing from a CD standpoint. But MHDD is the tool that I'm looking for. I'm looking to do some basic diagnostics and kind of get some feedback. And just to kind of give you an idea of what it looks like if I was able to do a reverse image, because this is what we're dealing with when we're dealing with sectors that are damaged and you have a product that can only do sequential imaging. You want a product that can skip around. You want a piece of software or a tool that can skip around. And DD Rescue will be able to skip around. DD won't be able to skip around. So you'll have some issues with that. But at least from this standpoint, this is what it's going to look like. Now, this movie is going to basically be in the middle of an image, where imaging forward, where it hit bad sectors, would be where FTK and all the others would already fail. It's going to leave those sectors alone and skip them. And now we're going to come backwards, and we're looking at the data in reverse. And you're going to be able to see that. So this is what this tool does. Basically, it's kind of mesmerizing. You can actually see in hex as it's reading these sectors. And the ones that it's leaving alone have not been read. They're not successfully read. All of these going forward the first time were left alone. This was stuff FTK or some other tool could not do. And they would have just hung right there, and they wouldn't have completed. And so it stopped. This is the end of the movie. But that's the point, is that this was now running from the end of the disk backwards, and you saw that it was able to collect sectors that none of the other tools were able to do. The worst thing is that most of the other imaging tools, as they were going forward, when they hit the first block here, that would be done. They would not have continued. You get a little thermometer bar. You don't get any content in hex. You don't even know what you're reading. All they have is a little thermometer bar, goes across, reads content, and when it fails, you don't even know. You don't even have a clue. Most of the time, it'll end, it'll say successful, and you won't even have an image. So, well, there's a couple of key points. One is that it is reading backwards differently than it's reading forwards. And so some of them, like DD Rescue, that can read content in reverse, can actually copy sectors and continue on even after a failure, whereas other imaging tools like Ghost won't be able to do it at all. So you'll be able to go backwards and actually read content. DD Rescue, the only thing that DD Rescue really can't do is control power to the drive, but it does keep track of the sectors that it's copied, so it would do something very similar to what we've done here. It can skip around on the drive, collect sectors, and put them back together all as one unit, and leave that info alone. Yeah? No, this is actually a piece of hardware called a Deep Spar Disk Imager, and this tool actually can skip those sectors going forwards, and so it actually tracked those sectors going forwards, continued on, and then came backwards and did them in reverse. It's the easiest way for me to give you a visual because most of the other tools don't give you a visual. DD Rescue will collect data and it'll basically put numbers together, and you can try to look at the numbers, but it's not very visual from this standpoint, but it'll do the same job. So, and there's a -R for a rescue for a reverse flag, so you can actually go in reverse. So my point is that get away from trying to do some of these images or copies using some of those other tools, even some of the ones I listed. These slides are all on my website right now. I posted them this morning before this talk. So if you go to myharddrivedie.com across the bottom here, you'll see on the presentation page, there is a page that has, it'll actually say at the top, PhreakNIC, and you can just click on it and you'll see all these slides because there's a lot of technical information coming up besides just the crap that sucks. So another thing to kind of get out of the way is all these tools, vendor tools and stuff for warranty and stuff, want you to go and try their vendor tools and run them and see whether or not, whatever. Most of the time, they don't even know what the error codes mean themselves. If you actually talk to most of these guys, there's some generic code that comes back, and they don't even have a clue. Most of the time, they just say, oh, yeah, it's under warranty, send it in. And you don't get your data or whatever, but most of the time, it doesn't work. And then these other ones like Microscope and things like that, those tools are for working drives. The drive has to be already functioning for it to do something. It does a butterfly test, tries to read some sectors. Maybe you have one bad block it can't read or something like that. But if the drive isn't functioning, they don't do anything. They just basically eat your money. So from that standpoint, you're getting away from those kind of tools. And I probably shouldn't have to tell too many people this from this standpoint. If you're running any of the stuff that's built into your OS to repair stuff, and if your drive is functioning and you really want that data, it's a terrible idea to run any of these tools until after you've already got a clone or a copy of this drive. You could get a clone of it, and then at least you're fairly safe with regards to being able to go backwards. Once these tools screw up, you can't go backwards in a lot of cases. It just messes you up further, and you can't do anything. And then SpinRite. Where does SpinRite write the data that it recovers? Back to the same drive, right? So again, I think I've harped on that one in every talk. If maybe he ever made it so it went to another destination disk, because when that drive dies, it's over. And you can only make it worse. So from that standpoint, SpinRite can just make it worse. So let's skip that. Frozen drives. Everybody asks about, oh, well, why don't I freeze a drive because I hear it works? Well, it does in certain instances. There's a lot of reasons why it might work, where maybe contacts contract and they make better connections, or a head stuck on a platter, and because you've put something in a freezer that it contracts, and because metal expands and contracts according to heat, you actually might be able to pop the head off the platter. But look at what it does to the drive. So this is what it will actually look like after the drive is frozen. So if this is your last-ditch effort and you don't want to spend any money on it, then great, maybe that's a good choice. But if you're actually trying to be a little more scientific about your problem and solve the problem without doing more detrimental damage to the platter, that might be a good idea. What if this was wobbling a little bit? The head might actually skip across the platter. Yes, sir? You still have a little bit of a condensation problem and a little bit of, I mean, even just with changing the disk and causing that to actually happen, even if there's no condensation, you can still cause other problems like the wobble and stuff I just mentioned, where you're actually throwing the balance of the platters off. It's very much like a car tire, the way that they're actually balanced with the screws and everything. And even one screw coming out can actually make a difference on the platters and how they spin, causing a head to skip across the platter, doing damage. So I'm just not recommending it as your first round. I mean, maybe at the end when you're at, yeah. You can freeze the board. Just make sure, again, that you don't have condensation problems when you actually take the board out and do something with it. And some people even try to heat them up. I don't have nearly as much luck trying to heat up a board, but there are certain instances where a CPU or a processor on the board, there's actually some problems with some chemicals that have been used in some of the processors, and heating them up actually make them work better. So there are some instances, but I have another way of controlling that. Using like a Peltier cooler, like ceramic cooling, you can do the same kind of thing and stick it on there, and it'll actually work a little bit better. So, all right. So one of the other, I don't know what's going on with this. Maybe one of these things is interfering. All right. So one other thing I want to talk about real quick is smart data, because a lot of people think smart is oh, it'll tell me about my drive and it's going to die or something bad's going to happen to it. It's horrible at predicting failure. Basically, smart it will ultimately take numbers and compare numbers together, trying to come up with a result to try to tell you whether your drive is going to fail. And then most of the time, maybe on your BIOS or something when you're rebooting it, it might give you an answer. But let's talk about where smart data comes from and how this is actually going to help you understand your drive a little bit better. All right, so your drive goes through basically a post process, very similar to what your motherboard goes through. It's not just your drive comes on and then there's data coming out of it. It actually goes through this entire initialization phase, and so there's actually a whole bunch of things that it goes through to do self-check, spin up, unmount the heads, make sure everything's reading fine, reads the servo information. Servo is basically feedback from the platter that actually says where the heads are. And then there's this thing called SA reading. Well, there's an area called a system area, and so somewhere on the platters, there's actually a location that stores unique data about this drive. And when I say unique data, I mean things in most cases, especially modern hard drives, almost all of them are storing things like an HPA area, host protected area, or serial numbers and model numbers. So if you happen to get a drive that doesn't mount and things don't work quite right, maybe if you read something from the system area, you can actually determine how far in the process it made just by the content that it gives you back. So let me give you kind of an idea of some of the other stuff in here. So you've got smart data, system logs, your serial number, model numbers, your bad block list. These things are all in this system area. If you get feedback from any of these things, regardless of whether or not you read your user data or not, you know that at least the head read that content. And that will tell you a lot about the state of your drive. So for instance, smart. So smart, basically, it's terrible at predicting failure, mainly because it's just comparing these parameters. It basically lacks standards. This is one of the other reasons that smart, which was self-monitoring analysis and reporting technology, which was supposed to fix this problem by telling us drives that are failing in advance. Basically, all it does is say, oh, I got a bunch of bad blocks, and as my bad blocks are increasing, I need to actually do something. Does Windows track smart? Does Windows do any kind of smart tests right now? No. Currently, none of the previous versions of Windows do any kind of smart test. Your BIOS? In most cases, here's the sad thing. Most of us are concerned about how fast our system boots, and so are manufacturers, and so are the vendors of the drives. So they turn smart off most of the time so they can improve boot time, and they can improve the actual response time, because smart actually takes time to do those tests. So in a lot of cases, they're wrong. The other thing that's really, really bad about smart is regardless of whether or not it's on or in use, the drive does not need smart to function at all. Smart is completely worthless to the drive. It's only to report to you some parameters back whether or not there's a comparison or not. But for the most part, smart does nothing for the drive to run, but it can stop the drive from running altogether. So in other words, if the drive had a failure while it's writing to this table, there's not a lot of code to do error correction for the content written to the table. So if the table gets corrupt when the drive is trying to read it back and just trying to read this simple table back, it will cause an exception failure, and the drive will actually fail and go into what's called safe mode. It will not read the rest of the ROM and will not return to a functioning drive just because there was some corruption in this smart table. But it's worthless to the drive otherwise. Yeah, so the very first thing data recovery people do usually is clear the smart table. this is what this stuff looks like. Most of the time, like I said, when you and there's a lot more to it than this, but most of the time you'll end up seeing, well, what are these numbers? What are these thresholds? What are the standards? Well, there aren't any. So basically, this ends up being worthless data. But what is good about smart data is if you happen to see, just like serial numbers and model numbers, if you are able to read data back from the smart table, then you probably at least have a basic functioning drive. You might have actually made it through the firmware and the PCB board and the system area, which tells you a lot about the drive, because at this point in time, if you made it through smart and you read smart and it returns data, even if you got no user data, you know that you probably have at least a good head. Maybe not all the heads are good, but the system head is good, which is needed to read that information. And that means that your board's probably in good shape, that your board probably actually functioned. There's a few exceptions, and I'm going to try to talk a little bit about exceptions because that's kind of the focus of what I'm doing here. You people are all basically using USB for everything. Like, let's use a laptop, plug in a hard drive, let's do a data recovery. USB sucks. Did you guys not remember how bad USB was to begin with in doing things? USB has no control over this drive whatsoever. When you plug the drive into USB, a mass storage driver starts up, and Windows starts this little API thing that talks to the drive. It's generic. It's very generic. It's basically, hey, okay, you got some data, give it to me, and that's it. But when it comes to actually doing data recovery, like most of you probably have drives that if you actually plugged it into a real ATA controller on a real motherboard, which I know nobody's seen these things anymore. Apparently they're all, you know, ooh, I bought a Dell and it's in a case, and nobody knows how to get to the motherboard anymore. But ultimately, that's the issue, is that if you plug the drive actually into the motherboard, instead of trying to use USB to do a recovery, you would fix a big portion of your problems. Probably 60% of the stuff that you have that actually had problems, you could probably read just by plugging into a, and again, motherboards have crappy ATA controllers. The ATA controller that's on there is, you know, sold to the cheapest manufacturer of the week or whatever it is that they did from some Chinese manufacturer. If you actually bought a decent board, and the funny thing is that some of the decent boards are actually cheaper than anything else out there right now, because RAID controllers that actually support just regular IDE or regular SATA drives, they don't have to all be set up as RAID. Older ones like Adaptec 1200A controllers and stuff were fantastic boards in their day, and they're a PCI controller, and they're only like 12 bucks on eBay. But because they're old school technology, everybody's moved ahead to the new stuff. Nobody went out and, you know, and still bought and still using those controllers. So even buying a really good controller that was 3 or 4 years ago, it might not give you 100% of the support for all the changes today in ATA Standard 8 or whatever, but you can still use that to do a fantastic job on recovery. So ultimately, that's the first thing I would say is make sure you're using the ATA controller, getting a better controller, trying to do something else with that. Using some software to look at the status lights. We're going to do this in just a second. Some people are stuck with trying to do things with eSATA, and they might only have a laptop. Believe it or not, the control set, you can't use it through USB, but if you have an eSATA card in your laptop, it actually will respond to the ATA command set, and you can use a Windows version of what's called Victoria and install a driver for your eSATA card, and you would actually be able to control it through a laptop and do the same type of recovery stuff you would be able to do, but you can only do that on eSATA, not on USB. Yeah, same problem. Yeah, you don't have complete control. You have more control, but not complete control. And then PIO mode. So I've mentioned this before in some other talks, but it's really simple from a standpoint of almost all your controllers are currently using UDMA to do transfers. And in certain cases, you know, it's kind of like our old problem with CD-ROMs where you had, you know, 1X, and when you went to 52X, all of a sudden there were some problems writing because it was trying to do things too fast. Well, in certain cases, just switching your controller to PIO mode, which in Windows is just in the control panel, there's a way to do it. You can go switch the adapter to PIO mode instead of UDMA mode. Believe it or not, I will tell you probably 20 or 30% more of the times that you can't read data or you can't read in reverse will be solved with that. Just go to PIO mode instead of using, and so if you're on Linux, there's other ways to do it, but ultimately you'd be able to read more content back from your drive than you would be able to do any other way. The only thing is it's going to be about 5 times slower than doing it through UDMA, and then doing it in reverse will add another 5 times slower. So if you're doing it in reverse in PIO mode, it's 10 times slower than it would be if you were doing it through UDMA, or approximately. Exactly. That's my point. Any kind of reading. But that will end up being a problem, like, you know, you're still kind of blind as you're reading the data. It may take a week for you to read, you know, a 200 gig drive. But most people, that's one of the situations where hardware is going to be much faster. It will solve your problem faster. You'll know what's going on faster. But you may still be able to solve your problem for free instead of sending it to somebody for $2,000 to do that job, if that makes sense. But you might have to wait a week. There's nothing about data recovery that's fast. I'll tell you that right now. The fastest thing is the FedEx guy bringing it to you. That's the fastest thing in data recovery. Nothing else is fast. So keep that in mind as you're looking at these other things. DD Rescue being free is awesome. Media Tools Pro is $300. X-Waves Replica is one of the other few pieces of software that actually does imaging in reverse. And I listed a couple others. There's a $40 piece of software called Speed Clone that does it in reverse, but you don't have much more control over anything else. But basically, that's my list of the basics of getting you to this spot where we can actually now start looking at some diagnostics things. So this is, and you're going to see my brainstorm here in a minute, which is going to look like a colossal mess. But ultimately, this is kind of the list of things that I go down when I'm trying to do a basic kind of diagnostic. So you can go get this off the website. I'm going to break every single one of these down as I go through it on the pages following this. But ultimately, I'm looking to see if the drive comes ready. Am I getting a response? Do I actually get some sort of lights, or am I able to read serial numbers, things like that? Does the motor spin, scraping sounds? So here's my flow chart. Okay, this is not all of the possible choices that you have for diagnostics, but it's kind of just a quick mind map of the things that are possible for you to do on your own, and then just kind of where to stop. Because there's going to be a spot where you go, look, this is beyond what you can actually do. So again, this is up on the website, so you can go download it. You don't have to memorize what I have up here. But so I'm starting here. Basically, the yeses go this way, and the nos go this way. And so I'm basically going through each step and then trying to figure out what each step of it is along the way and what my choices are. So let's look at it. These are some of the exceptions that I want to talk about. So for instance, if I got a drive in and it's a Seagate drive, normally anything that was before, say, December of 2008, I might be able to just start doing diagnostics and do a basic thing, and it would be the same for all drives. But there are some exceptions to everything. So for instance, if I know that I have a drive that's labeled 7211, 7212, that they have a specific firmware problem, and that firmware problem exhibits itself in two ways. One is I can read a serial number, but I don't get a size. So I actually get the serial number from the drive, but I don't get a size. Another one is that it always stays busy and never comes ready. So those are two of the symptoms of a firmware failure that would be exceptions that normally would not be the case with the drive under other circumstances. So there'll be a few of those, so I'll go through a couple of those. And then I'm going to talk about Western Digital, the same kind of thing with what actually happens with them, and then the common things that all the drives can have. So Seagates, these are the basic things. You see this label and you see a 7211, the very first thing that you should be thinking is, hey, I probably got a firmware problem if the drive doesn't come ready or if I can't blah, blah, blah. So just keep that in mind before you go, hey, I need to replace boards or I need to replace heads. You just stop and think here. Now, if you want to know a little bit more, you can. So here's a link basically to go get this cable. This is a USB cable that basically you can rip off 3 wires off of here. So here's the wires you're going to need. An orange wire off of this cable, which is whatever it is in here, orange, and then this one that's a yellow wire. And on a 7211 or any Seagate drive, Seagate is the only drives that have a direct connection through a serial port that you can monitor just through terminal or through anything else. You can just plug them straight in, set the baud rate, and then talk to them. And I've got instructions out there on how to do that and do whatever, and I have the other diagrams on another website. If you just hit my site, you'll actually find them. But basically, I'm going to plug the orange wire into here on the SATA connector, and then the yellow wire on here. These are usually the ones that actually control speed of operation. Those are serial ports. And then I'll actually see a screen, and I can start to find things out. So this is an example of a screen. Now, this particular thing, actually, as soon as the drive powers on, it will actually start to tell me content. It'll actually say, oh, here's my model number, here's my drive, here's the things that I can do. And then if you have a head error, it'll actually say HM, and it'll say head mask error, and you'll actually see that go across the screen. So those kind of things you can actually fix by doing head replacements. If you know enough about them, you can actually go through the process, which is what my other talks have been about. In this case, I'm going to tell you where to stop. In this instance, this is going to be a video, and this is what's actually going to happen if you have a problem you cannot fix. One of them. This is called a pending bug. So if you see this scrolling past your screen like this, that's where you stop, because there is nothing you can do without special equipment. You need a special $7,000, $13,000 box in order to fix this problem. Your data is completely fine. In most cases, your data is completely fine. Your problem is that there's a bug in Seagate's firmware that actually says, hey, look, I think I got a bad block. Let me check the next block. And it'll go through this cycle over and over and over again. And it basically causes the CPU on the drive to become busy. And what it'll actually look like to you if you were trying to image it, if I was to show the imaging picture before, you'd be reading every other sector or every other block of sectors. It would just read every other block, and you'd never be able to read the block that you have. And so you could probably whittle it down, but it will take you about 7 years to read like a 250 gig hard drive that way. So just because of the timing problem and the problem. But initially, for this $25 cable, you can see most of your diagnostic stuff on Seagate's. Western Digital doesn't do that, so unfortunately you don't get that for your benefit. But that would at least be a place to start and get a good idea. Western Digital has a different set of issues. So Western Digital, if you want to see what the inside of your drive looks like, so this is one of the first things that people seem to be doing is like ripping the lid off of the drive and looking at it to see if it's okay. On most drives, that's actually okay. You won't do damage to it unless you like spit on it or put your fingerprint on it or something like that. But that's not true on Western Digital drives. Western Digital drives, you need to stop opening the case and looking at the platter unless it's a last resort. There's a little nub, basically, that comes off of the lid that comes through the top that screws directly into the head assembly. And when it screws directly into the head assembly, it helps the alignment. They basically, at manufacturing time, use the lid and the screw through it to align the drive. And so when you take the lid off, in a lot of cases, you change the alignment. So if the problem wasn't the head, and you didn't know that, and you had no other way of determining it, you just made your job worse. You just made everything worse about doing this recovery. So at this point, you stop and you do all your other diagnostics without removing the lid until final destination. If that happened, even in data recovery in our world, if we actually have to do something to repair a Western Digital drive and we had to replace the head assembly or something, this is a tool that we would have to use. This tool is $750. This tool basically is a set of brackets that holds the lid and everything in place, and then it actually uses pushing this lid around and the screw through here to help the head alignment until we can read the data off of it. So that's going to be very difficult for you to deal with. I've dealt with a lot of different chassis and things that can do that. Maybe you can rig up something with a coat hanger or something. I don't know, but in this case, it's not cheap and easy to actually do. So I just want to stop you from ruining the head alignment. Most Western Digitals are not head problems. A lot of Seagates are head problems. Not a lot of Western Digitals necessarily are head problems. A lot of Western Digitals have board problems. So in older boards than the current board, you might see this. Now, this is one of the things with swapping boards with Western Digitals. Seagates and some of the others don't have a serial chip, but some drives do. Some variations from all manufacturers have a serial chip, but they're just not as common as they are in Western Digital drives. Western Digital drives have this chip that's called a U12 or a U5, and this stores parameters for the drive. And the parameters that are stored are necessary for it to function. All the things that are special in order to get the heads to line up and talk to it are in this chip. This is a very small 8-legged chip. It's really not very complicated to resolder this chip. It is fairly easy to take your board that could be burnt. You could have had that burnt chip that I showed in the beginning of the slides on this board, and the board wouldn't function. But this chip still contains the data. So you get a new board that actually matches that one, or you get a new drive that matches that one. You unsolder the U12 chip from that one and throw it away, and you take this one off. Your hardest part in trying to solder this thing is, one, you don't melt the chip, and two, you don't turn it backwards. If you turn it backwards when you solder, and usually when you're soldering, you're covering it with flux or something like that, it gets hard to tell what the label was, what direction. Take pictures ahead of time, and then you won't doubt yourself when you're putting it back on the board. There's some easy ways to deal with this. I'm going to show a quick soldering thing, and you can do this cheap and do it on your own. You can swap boards all day long. And this is actually the majority of probably Western Digital fixes up until the newest rev of drives. The newest rev of drives have a board that has this triangle shape to it. All the others had a different type of shape. They all had like a square shape and stuff to it. This particular one that you see, if you see this triangle shape, there is no U12, there is no U. The code is actually in the chip itself, and you actually need a special tool in order to copy the content. Even if you can actually connect this board directly to a system that has the special equipment on it read the content off a board, write it to another board, and be done. There is a particular problem with some of the newer Western Digital drives. They will appear that you can copy the drive fine till about 50%. Once you reach 50% of the drive, all of a sudden there's a problem. And it sounds like a head failure or something else. But the drive read the first 50% just fine. So you got a 500 gig drive, you read 250 gig sequentially, and then all of a sudden it fails, and you can't read anymore. That is a PCB board problem. They actually have like a separate set of fuses on this board. And so in order to fix that, you actually have to copy the code from this one to an actual good board. So you actually have to go get another drive, image the whole thing, make sure it works correctly, and then copy the code off of this onto the other device. So unfortunately for you, you need a special tool that can read firmware and write firmware back to the other board. So that would be where to stop with this particular one. So there's not going to be another way for you to swap out that board and do something without some special tool to read firmware. You could do the swap out of the burnt chip as long as the burnt chip wasn't like the CPU or something like that. Yes, right. In that case, you would already be done anyway because you wouldn't be able to read anything from it. I can actually have burnt chips on the board, and the board will still come ready by itself without a system or a drive attached to it, and I can still copy the code off of it in a lot of cases. Even sometimes with the U12 chip or the U5 chip, I can do that without having to resolder things. But those are so easy to resolder, it's not really a big problem. You can do those yourself and not have to deal with that. And then you're over. You cannot do that job without that. Yeah, I mean, the closest you can get is to try to get something that was like within a day or two in the hopes that you actually have similar, what's called adaptives, but the chances are slim. It's a lot more expensive and a lot harder to do. But the U12 chip, I don't think I've ever seen an actual burnt U12 chip. I'm not sure I've ever seen one that was burnt. Usually it's a motor control chip or something else. I'll show a couple more pictures. So this is where we're at. Basically, we're starting to look at firmware, head damage diagnostics, and going through that step. MHDD is a free piece of software, and it can help you do diagnostics. And the way that it does this basically is actually talking to the ATA controller. So if you have a decent ATA controller in your system, you can talk to the drive, and it will send commands back and forth, and it will give you some basic stats. Is it perfect? No. Is it the best? No, but it's the best free thing probably. What I'm looking for is this stuff up here. You'll actually see these control lights across the top, and there's two sets of flags. There's going to be one set of flags that actually tells you the state of the drive, which none of the other imaging tools, by the way, showed you this content. These are actually states the drive returns in ATA commands and ATA results back that says, hi, just like a courier modem might. These are actually the same type of results you would actually get back. It even looks very similar. And then over here on the right-hand side are your error codes. And everything in the error codes actually means something. And so I'll show you a real quick example, but there's more research on that out there in my previous presentations. You might want to go back and view those about the error codes. But ultimately, if I plug in a drive, and so for instance, if this was a Seagate F3 series, the 7200s that I just talked about, it would just stay busy and would never come back in a result. And so that basically is a firmware error in most cases, 99% of the time. What I'm looking for is this status light here. I want drive seat complete and drive ready. I want those two things to come up. And then I could actually try to actually get some information back from the device itself to see if I actually have a serial number. So, and this is, again, newer drives pretty much since like 2002. I don't know how many of you are dealing with drives older than, say, 2002, 2003. There may be some different things with some drives before 2003 where you get model numbers and stuff differently. But almost every new drive since 2003 or 2004 has done this way. So this is basically a quick idea of the types, the flags that you actually have in the top right-hand corner. This is what a sector actually looks like. So when you're looking at a drive, it's not 512 bytes of data and it just returns it. There's a whole bunch of crap that goes with it. So there's a whole bunch of things that have to do with addressing and sync information, null bytes, whether or not have a relocation flag, and all those error flags that were up there on the right. Those all mean something with regards to which type of error it returns. And the ATA command set actually will return those in a result. So if you actually got something like AMNF, you'd have address marker not found. It means it knows where it is, but it had a spot right here where it didn't know what the go signal was going to be for the actual 512 bytes of data. So go back and look at some of my previous material on those, and you'll actually be able to break those down. I don't have enough time to cover all those here. But they all mean something, and you can use MHDD for free to try to figure that out. But the trick that I'm looking for here is, did you see a serial number? If you got a serial number, or as I described earlier, the smart information, if that stuff came back, then you probably at least have a good system head. You may still hear problems. You can actually still hear a clunking noise or a couple other things, but that doesn't mean that, if you can read some data, at least some is better than none. You may be able to deal with those. And there's ways to read data with a bad head. So one of the other things that happens a lot, and a lot of you have probably seen this, where you actually get a disk that will show up in disk management in Windows or something, but it doesn't say healthy, doesn't say NTFS, you're missing all your content here. If you got this, don't replace stuff. In most cases, you're not dealing with a firmware problem. You may still have a head problem or something else is going on or something, but ultimately that meant that I read some data. If I even got this far, I got a partition table, I've already made it through initialization, I've already made it through the main portions, I probably have a functioning board, I probably have firmware okay, I probably at least have a good head. So that would be a bad thing to do. And I've seen this a lot of times when people go, I saw this, but it didn't work. This is probably corruption of some other kind. If any of you are any good with electronics and stuff, you can also use an oscilloscope or a meter. Again, this is probably a topic that could take a week by itself, is how to attach oscilloscopes and meters to boards to test them and do electronics repair. But there is a way of actually using an oscilloscope or a meter to tell whether your board is working correctly without having some fancy equipment that actually runs through all the tests. This is an oscilloscope, and this is basically telling me right here, in this particular case, I can tell a lot just by looking at this particular graph, because I have a 12-volt signal and a 5-volt signal. And so that means I have a 3.5-inch hard drive, because 2.5-inch hard drives don't have a 12-volt signal, they only have a 5-volt signal. So you end up with a situation like this where you'll have a 12-volt. This will actually be, the motor spins up. I actually get, you can kind of see how it staggers. This is actually going to be head assembly as it starts to work. So you'll actually start to see how the movement and what is actually happening in that power consumption in the processor, and you'll actually see you'll be able to tell whether or not it's functioning correctly or not. If it wasn't functioning correctly, and this was a 3.5-inch drive and 5 volts was completely dropped, then I probably have some other kind of problem or board problem or something along those lines. But it's just one more way in the list of things to know that you can actually tell. But what if I don't have that kind of information? What if I don't have that kind of equipment, or I don't know enough? As I already said, serial number, smart information, blah, blah, blah. But there is something that will tell you something else just by visual examination. And again, this is one of those things where you have to remove the lid of the drive. So take precautions when I'm talking about removing the lid of the drive to actually do something. If this is like your corporate networks, system, and you wanted to, do a recovery and you have to have it, don't go playing with stuff until you actually understand what's going on. So get 20 drives and play with them first and try to understand what's going on before you start doing this. So here's the thing. Basically what we're going to look for in this, and I have a video coming up, I'm going to look for the heads seeking what's called the system area. So the system area can be in 3 or 4 different places on the platters. So it may be on the outside edge, it may be on the inside edge, it may be in the center of the drive. But when you actually see the heads move to read the system area, it's very intentional. You'll actually see the head actually move to that location, it'll jerk for half a second, like it's reading something, and then move again. And so you can tell when it seeked it and where it actually read it from and know whether or not you've got it. So this is what I'm going to say. So this is going to be what you're looking at. Yeah, you'll actually see head move, seek it, and it'll do it on purpose and move purposely to another location. I powered off to do it again, so you'll see it one more time. But so you'll see the head will seek, it'll move, it'll do it intentionally, move to its correct location, and it actually read a system area. So at this point in time, I know my firmware is probably okay. There's a few exceptions, but for the most part, my board's probably fine, my firmware is probably fine. I got to the head assembly, which means my preamp is probably fine. So that means the basics of my head assembly are actually working. And I can tell a lot just from the function of seeing that happen. So I don't go rushing out to go get a board and try to do something else with it. Now, if I had a damaged spot where that head was, that is damaged SA. So this is actually an SA area that would have been stored in the center of the platter. Something happened to the head while it was at that location. Maybe it was dropped while it was shutting down or something, and then dug a big old hole right in the middle of that platter. And so that destroyed the SA area. That's crucial to the drive's function. And in many cases, it's crucial to actually doing a data recovery. There's only a few exceptions to how you can get around this problem. One of them is doing something called a live hot swap. And I talk about that in other talks, so you can go see other videos on that. But there are ways of repairing that, but your functions are now limited. You're probably down to a 30% success rate or something in that neighborhood. It drops dramatically. So head problems. All right, so here's a sound, and hopefully sound is working okay. All right, so what I'm going to try to describe here is a clunking problem. All right, so a lot of you have heard like a drive start up, and you can hear it intentionally go to its location and read content. But there's two other sounds that you hear quite a lot. One of them is tick, 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 and then there's a clunking sound. Most of the time, a clunking sound will mean that you have a bad head. Does it necessarily mean you can't read data? No. But it means you probably have a bad head. And if your drive still comes ready and still reads content of any kind, serial number or whatever, then the bad head that you have is probably not the system area head. It's another drive, another head on another platter. Okay? And that's important to know because there's still a possibility of reading all the others. And so I'll describe that in a second. Here's what it'll sound like. Or something similar. I mean, it'll sound fairly much like that clunk, 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 clunk. And that's an older drive, so it'll sound a little bit different on older drives. But it's still the same repetitive pattern that you'll hear over and over. Sometimes after doing that and starting it up, it takes 3.5 or 4 minutes before the drive will actually come ready. But if you have MHDD on and you can see the drive and actually come ready, and then you can do a Shift F2, you can actually get a serial number from the drive, you at least know the SA area head was good. If that does that for more than 3.5, 4 minutes, then you might want to shut it down and figure out whether or not you can do something. You can still do damage to the drive, obviously. If you've got a bad head, you probably have a bad platter or something else that's actually scratched. Basically, the system keeps resetting the head to actually go back and read a sector. So it'll actually continue to hit that back and forth. And so it'll actually cause the head to actually go back to its park position and return very fast, quickly, a dozen times. So you'll end up in a situation like that where you'll hear that clunking sound. This is what it would look like. So in this particular instance, I've got a stack of heads, and this is the head that's missing. So you'll actually end up with this position. Now, I'm actually doing a head replacement on this. I was successful on this drive. I had to do 2 or 3 actually to get all the data off of it. But basically, I'm protecting the heads as I took it off with a foil tool that I made out of basically like gum wrappers and stuff like that, the hard ones that you actually poke your stuff through on the plastic. You can make those. I have videos online about how to do that too. But you can actually do a head replacement. Don't rush into doing the head replacement because that one bad head doesn't mean that I can't read other data. I can read other data. Let me give you an example. This is what it looks like if I was to sequentially read across this drive till I hit the bad head. So what happens here, this is block 0, LBA 0, which is sector 0. They mean the same exact thing. And then as I ran along the drive, I was able to read this chunk of data. So maybe I had 4 heads on this drive, and maybe this was the 3rd head that was bad. So in this particular case, I read all this data, and I was able to store this data. Then where it was read, I wasn't able to read anything because now I have a bad head. It will take tremendously a large amount of time to read that bad head, to read the content from that bad head. So it'll look like it's imaging along and be fine for a while, and then bam, it'll just start looking like it's corrupt or doing something. It has to reset this head for every error, every time, for every sector. It could take forever to do this. But it's still possible that I might, with the right equipment, be able to turn this head off, read the other data, and then fix that one head and fill back in the data I'm missing. Because the more that you swap heads, the more detrimental it is. Sometimes it's hard to actually take like a stack where you actually have 10 heads and get all 10 heads aligned, but you might be able to get the one bad head and the system area head realigned and get those 2 done, read the data, and fill the holes. Does that make sense? You guys? Yeah, it is cool. It's really awesome. So, for instance, and people think that, oh, well, look, what if I read the 75% of data and I had this one bad head, then that means I have nothing. Well, that's not true either. Now, in this particular case, maybe, because this is at sector 409-600, and just off the top of my head, I know, anybody know what's at 409-640? Anybody? You Mac people. Whatever. No, the beginning of the MAC sectors for where the catalog is stored is at 409-640. So the actual spot where the binary tree for the MAC's catalog is going to be right about here. So if I don't get that, I don't really know where my data is. Anyway, so back to what I was talking about before. If the data is, let's say I have 4 heads, one of them's bad. Does it mean I don't have anything? No. All right, so data is stored. It used to be in the olden days, data is written above and below every platter all the way down, and it's not done at the same time. It actually takes time to turn on and off each head. So basically what ends up happening is you have a latency problem. If you have a stack of heads, everybody thinks, oh, well, they're all writing in parallel. That's not true. They are writing one at a time, and they have to turn them on, turn them off. So in this particular case, what they said is, well, what's the fastest way for us to write data? So the manufacturer maps out the data that's on the platters. And so in this particular case, you'll actually see I have zone 1 on this head, and then I'll have this many sectors. So I'll have start of LBA 0 to 4 million. So I'll actually have a chunk. I'll have 4 million sectors that are in a row consecutively on a device before it will turn to the next head. So if a different head is bad, I might still read, I mean, in 4 million sectors, I might still have, a 3K Word document or a picture or something like that. I might still have enough that I can actually make something out of it before I had to switch the heads and then try to fill in that hole with the bad data. Okay? So I will read 75% of the drive. I'll just turn off the bad head, and I have a piece of equipment that actually lets me do that. You could still read it. It's just going to take you a lot longer, and there's always potential for more damage, just so you know. But there's a possibility of actually doing that, or turning the head back on and then reading the rest of the data. And then this is another picture of the actual tool as I was inserting it. This is on a 2.5-inch drive, how I could actually repair the heads, replace the heads, and go through that process. There's one other thing that happens with drives when you have a head that's stuck to a platter. You guys know what stiction is? Everybody remember stiction? So the lubrication or something would actually dry, the head would stick to the platter and it wouldn't move, and there wasn't enough force for the head to break free, so the platter just stayed still and didn't move. So when you're listening for problems, you're listening to say, well, is this a head problem, is this a platter problem? Well, it's kind of a toss-up what problem that categorize this is. But basically the head is stuck to the platter. This is the sound you will normally hear. So you hear something that sounds like Star Trek phasers. There's another one that happens a lot too, and it's this one. You hear that? So that's a head stuck to the platter. So in most cases, I can do a couple of things, but basically what I need to do is break the head free from the platter. And so, in the old days with stiction, the common thing was like to whack the drive or something like that. That's not very scientific and can cause more problems. It's a lot easier if you know, hey, this is a Seagate drive, not a Western Digital maybe, and open it up and be able to actually create enough tension to move the head. Normally wherever the head is parked is going to have bad sectors on it, and you're going to have trouble reading it. So I'll show you a picture in a minute of a way to break the motor free, because I have a motor section on how to actually do that. But those sounds are the sounds of a head stuck to a platter. Those are actually fairly good signs, because if the head's stuck to the platter, then it means you actually probably don't have any functioning problem, that once we actually get the drive spinning, it will work, and you'll just lose a couple of sectors, you'll probably be able to read the rest of your data fine. So that's pretty good. There's a simple thing that's called TVSs. So TVSs, and you'd be amazed at how many times that this is actually the problem. They have a voltage suppressor. Basically, it's a fuse. That if there's static electricity or there's too much voltage or something comes across, it just burns this fuse. And it happens fairly quickly. So you'll see like Seagate 640s, you'll see a lot of Western Digitals, a lot of IBMs. Most of those will all have this kind of sensor on. Not many 2.5s, I don't think that I've seen them, but typically on 3.5-inch drives. So near the power connector somewhere, you'll see these two black things. They'll typically have one connector on each side. And so the bigger one is usually your 12-volt sensor, and the smaller one is usually your 5-volt sensor. So if you power on the device and the motor doesn't spin, you hear nothing from it, look for these. These things will be in a couple of places, so you might see ones like this. And believe it or not, all you have to do, all they do is suppress the voltage. So when they're not working, they short the board. It doesn't work. All you have to do to fix them is this. I'm not kidding. Like, this is like 40, 50% of these drives. You take a pair of pliers, you go find your two, and you rip them off. And that's all you got to do. Now, you can test them with a meter and go through this other process to see. And obviously, if you're not planning on using this drive again, fine, rip them off or whatever. I'm not saying just go gung-ho and let's go rip stuff off of boards and stuff. But I'm just saying that that's a potential issue. If the motor doesn't spin and you've got these TVS chips on here, fairly easy and quick to actually fix if the motor's not spinning. It does not always mean that that's the only one. You have to refer to my flowchart from previous of the other things. Electronics and burning chips. So basically, a lot of times, people kind of want to know, well, and occasionally I get lucky and I catch one of these on video. So that's what I did. I caught a burning chip on video. So this is what it's going to look like. And if you watch this corner right here, this is the area you want to look at. Okay? right? And then smoke comes off and the whole thing. So that's what happens. Now, this is the motor control chip. This particular one, I know it looks a lot like those serial chips and stuff, but basically the serial chip is somewhere else on this board. But this was the motor control chip. And so in this particular case, all I had to do was move my chip, my serial chip, or in this case maybe even just replace the board because there may not have been anything unique on this board. But that is typically what it'll end up looking like. Like you'll actually end up with a burnt chip on it. And this is the motor control chip. And you'll see things too, like if you do a comparison between them. So this is another board, and you can see, and it's really hard to see when you're looking at a whole board. If you actually had this whole board in your hand, it would take you a little bit of looking to actually see that it's burnt, even though it looks really obvious on here. It looks great when you actually blow stuff up, but it's sometimes hard to see. And sometimes you'll actually see like a little ding in a chip, or you'll see a crack like this in the chip, but you won't actually see the burn marks. You can almost always smell them. The smell of the burnt chip is actually a good giveaway all the time. And I smell a lot of drives. What are you doing? Seeing if I have heroin on. No, anyway, so that's one of the things you can do. In this particular case, it would be easy to unsolder this chip and move this chip. Anytime you have a question about what chips are, too, most of the time, unless they're burnt up, you can't see the numbers. But you can typically type those into a website somewhere, and somebody will tell you what they are. So it's not usually that hard to actually find out what they are. So let's talk about soldering for a second. Before a couple of years ago, soldering was a big deal. It's actually a lot of work in a lot of cases and a lot of damage to desolder a chip and then solder it someplace else. So these guys came up with something a few years back called ChipQuick, which has actually been the savior for the cheap or the hobbyist kind of guys. Most of us have to go to what's a higher end, like air soldering, desoldering equipment, which I actually have, and I can show some pictures of that. But let's say on the low end, on the do-it-self cheap stuff, this is what you're actually going to look at. This, the actual ChipQuick itself, now this whole container is like $100, but the ChipQuick itself is only like $18. So you could just buy the ChipQuick, get a halfway decent soldering gun, and do this stuff yourself. So let me show you from ChipQuick's site what this basically looks like in like a minute.
ChipQuick is essentially a low melting point solder that when heated remains molten long enough to release all the pins at once on a surface mount chip. Watch how long this drop stays molten. To desolder a chip, first apply paste flux to the pins, then mix in ChipQuick solder so that it covers all the pins. Now continuously heat all the sides until the chip can be pushed off.
And it really is that
pads
easy.
With solder wick, or as the manufacturer
And then
recommends,
do it again and basically solder it back
lots
on.
of flux.
But it really is that easy, and even for complex chips and stuff, but it might take you 30 minutes to kind of get the hang of it, to actually get it down, instead of the 30 seconds that it took him to do it. But I have done fairly complex chips and been able to actually move them and do whatever. But trust me when I tell you, take pictures of them before and after so that you know where the alignment is and everything is before you actually turn the thing on. Because a lot of times, I mean, you rotate the chip one way and just not remember, or sometimes there's a little tick mark on the corner or something. Double check it. Just trust me. You can do more complicated ones. This is called an air soldering and desoldering rework station. Basically what it does is you put your flux on the thing. You don't have to put anything else on it. You can heat it up to 400 degrees or so or whatever it is right before this board's going to melt, and then the chip will actually just pop right off. And I actually use microscopes. I have a microscope for going back and resoldering, and this is actually a picture out of my microscope of something more complicated. So if you end up with a chip that's way too complicated for you to do, and I do not suggest you do this directly on the board that you are doing your drive from the first time. If you have a drive and you know this chip needs to be moved, go practice with a couple old drives first before you do this. I have people that will actually send me emails like, hey, I need to do a head replacement. Where do I get this head from? Like, did you try 12 other drives first before you actually tried to do the one head you need? And then after they screw it up, then they're like, well, maybe I should have practiced first. Okay. All right, so let's talk about motors for a minute, because this is your other big problem. If the motor's not spinning or you have some other problem and you can't deal with it. All right, this is what it'll look like. This is actually just powered. I am not plugging in and unplugging the power. I am turning the power on, and I am leaving the power on. And it will just sit here for like, this is really like less than a minute video. But it will sit there and jiggle back and forth like this all the time. If I was just waiting for the system to think this was ready, it would never come ready on the system. But it is possible that I can actually deal with this motor in a number of different ways. It'll never start to spin up, so it'll never unlock the pins. The head will never move out of position. Look how slow that thing is spinning too. Jiggle, and then even once it actually starts to spin, it's still not spinning at an appropriate speed. So this is actually a fairly easy problem to fix. This drive will be useless when we're done with it, but for now, it's an easy problem to fix. So I'm going to show you a couple of different ways. Now, sometimes you might use a tool, something similar to this. Now, this is a lot like what you would use to turn off the water in your front yard or something like that. So you can actually take something like this, and it's a little dark, but basically what happened is I took out every other screw, and I attached it to this tool. This tool is about $100, but you probably can find a couple of different ways to do this. But basically, I'm going to force either to, if a head is stuck to the platter, I'll force it by turning it. If there's a problem with the bearings or something, sometimes pushing down, pulling up, and turning a little bit will solve this problem. Sometimes even just, you have to be careful. You're going to stick a screwdriver in there because if it slips, you just, scored your platter and it's over. But there's other ways to deal with something like this that's a problem. So this is the bottom of the drive. And you can't get to the motor. This does not remove the motor. This isn't going to come out. It's part of the casing and the capstan. It looks a lot like this. So it's actually part of the whole device. So it's not something that you're going to just be able to like pop right through and deal with it and take out a motor and replace it and your platters still be aligned. You have a problem if you have to remove those platters. And if you have to take platters out to move them to another drive, if they are turned at all, they will not work again at all. They need to be aligned perfectly, so you have to remove them all at once. So it's a lot easier if you can deal with the motor before you actually go this far. So let's say that I take this. Now, the big thing here to watch is your spacing. So your spacing for this copper, the whole point is I'm going to do a trick. I'm going to take a Dremel or a drill, and I'm going to come through the bottom of the motor, and then I'm going to lubricate it. And the whole point is not to puncture it so you hit this copper. If you hit any of this, it's over. Or if you get metal and stuff stuck in there, you probably won't be able to get it back out again. So in this case, I use a really small drill, and I drilled a hole that just barely punctures the metal. And as soon as I've done this, now if you use a Dremel or something, you might be able to like sand it down till you get there. I've used a couple different ways. It just takes a lot longer to do it with the Dremel. But so I know the alignment when I'm holding the drive. I know where each of these breaks are. So I have a pretty good idea where I can puncture it and not hit copper. So you might want to look at another drive before you do this. And then I literally can put WD-40 or oil in there. Don't put much of it. Put a drop or two because it sometimes it can come out the other side and come out around the capstans and then get on the platter and then it ruins your heads and so on and so on. But you can put a drop or something in here and then the motor will actually come up and spin. So one of the other things too, if a motor does not work and you cannot figure out, if you've already gone through this, you've already dealt with the PCB board, you don't get firmware, you play with the motor's spinning fine, you turn it and it moves just perfectly fine. One thing you want to know is it my board that's a problem because the drive's not spinning up, or is it something else that's a problem? So is it the motor maybe? Maybe there's actually something wrong with the motor in that even though it turns fine, the motor still won't power up correctly. So you can take another board, you can take another drive, the exact same drive, or not even the exact same drive, just the same shape of the board itself. And over here you'll actually see this spot. This is the spot that the connector to the head assembly touches. This part right here that actually touches the motor is the same on pretty much all the drives. So if you got a 5400 RPM, they're pretty much the same as long as they line up in some fashion. What you want to do is you want to cover this. You want to cover this with a piece of paper or label or something so that it does not make contact if you do not have the same board. But you want to find out your motor's working. All you have to do is cover this, screw it back on, and then turn the power on and see if the motor actually spins. Most of the time that will work. There are some SCSI drives that have delay sets and stuff like that it won't work on, but for IDE drives, SATA drives, things like that, you can tell whether or not the motor will spin. In a lot of cases then you know you have a problem with your PCB board if it spins with the other board on, but doesn't spin with the bad board. So you'll know you'll be looking at some sort of a PCB board problem. This is basically what it looks like where the pins actually come through. All you have to do is cover that up. So you take the 4 screws off, you just want to make sure whatever board is connecting. And then sometimes I actually end up hardwiring it to another board. Now this one, the boards didn't match, so I actually hardwired the motor to another board. And then I actually used the regular board and put it back on and ran the drive, ignoring the motor. And that one worked. So if it's more complicated than that, if you can't solve it with any of those things, then you're actually at a spot where you're moving the platters to another drive. This is another talk that I did on how to actually do that, but there's a special tool that you actually need to do that. This is $600. So you end up with a situation where it might be something that you got stopped, that you couldn't do anything with. There's other methods maybe, but this is the best and the most secure if you end up having to move platters. So we've kind of gone through the basics of these components right here: phasers, the chips, the electronics are burnt, does it smell? And then some of the others are going to end up being, well, what if the motor is spinning? Does it sound correct? Does it spin at the appropriate speed? You can usually tell if you're getting a motor that spins at the appropriate speed. If it doesn't spin at the right speed, the head is not floating as high over the platters as it needs to be. So it might actually lock down, or it might scratch the platters. So let's talk about scraping sounds for a second. That sounds beautiful, doesn't it? Yep. If you make a mistake and you don't assess the problem correctly, you could end up with this situation where you actually created the situation, and that's what it will look like. This whole outer edge will be scraped off, and this will become platter dust. Or in a situation like this. This is actually two platters. This is an IBM drive. They are glass ceramic platters, and you can see through both platters. This piece of paper is stuck below the bottom platter, and the heads have scraped off so much of the material you can see through the glass, and that you can actually see the pink below it on the bottom. What's that? Yeah, it's beautiful. It is beautiful. It becomes more artful when you take off the lid. This is the lid. And there's so much platter dust from some of these drives that actually comes off. It actually made an impression just from pushing the airflow back up with the dust that you can actually see the whole assembly. I mean, this is actually a beautiful piece of art. So you might want to frame it or something. A lot of people will ask too, though, what if it's not obvious? What if it's not on the top of the platter and I can't see it? How do I know if a lower platter is scratched? In a lot of cases, this is a filter. On the side, on the edge of a drive, there would be a filter, like here. If a lower platter is scratched, in a lot of cases, this filter will look silver. It's supposed to be white. It's not white. It's silver. That's white. This is silver. A little yellow, actually, probably from this. But so ultimately, if you have a scratch on a lower platter, that will be what your indication is. That's usually a good thing about, hey, I don't want to buy a donor drive. I don't want to spend another $200 on a drive that's not going to work and I can't get parts from. So that's usually a good sign there. There's a way to check this, though, to see if you've got platter dust or something is scratched ahead of time. So on the side of a drive, you guys recognize this? You guys seen this before? So this is basically, I believe this is all used at manufacturing time for head alignments and stuff like that. They can insert a tool and do the whole thing, and then they cover it up, and it says warranty void if you mess with me. So basically this piece of silver right here, if you peel it back, you'll notice these are the platters. This still can maintain pretty good air from a standpoint of not having to have a clean room or something like that, and you might be able to tell fairly easily whether or not you've got a scratch. It's not 100% all the time. I've seen scratches where the platter dust doesn't show up on the label, but if you do have platter dust right away, you know pretty much probably done for, depending on the amount of damage. So this is a silver one. You can actually see the silver, and it looks good. This is one that the circle is all black. And so here's another picture of it. So the circle is actually black, and you have their silver outline on it. So that's pretty bad from that standpoint. That's probably going to be pretty close to the end of that drive. And you can tell that at least without having to go to a clean room or something else to open it. So that's kind of the basic breakdown of this drive's been through a fire. So the big problem with drives that go through a fire is that you can't read the label in a lot of cases, so you don't know what the parts are that you need to buy. So that's your biggest problem. But ultimately, that's kind of my breakdown of the flow chart that I actually showed for all the stuff of how to step through it and do the basics. Anybody got any questions?
Yeah, thanks for making me really, really paranoid now.
Back up, back up, back up. Put me out of business. I'm all right.
So when do we get something better than hard drive? What's hopefully coming along?
2015, maybe.
Coming along to replace it?
Well, temporarily we'll have solid-state drives along the way. They have their own set of problems, and they have a lot of the TVS problems. The problems with a lot of solid-state and USB memory sticks have the same TVS problem. They're just a lot smaller. So they're hard to find, like SanDisk USB memory sticks have like 5 on them. You have to break off all 5 of them, and they'll work. The USB memory stick will work fine, and other solid-state disks have the same kind of problem. But there's something called domain memory, domain walls, and it's being designed by the same guy who actually manufactured and designed the original head that we actually use on our heads right now. He works for a branch of IBM, Palo Alto or something, and it's basically a solid piece of metal that pulses are stored in that can be read back at a faster speed than you can read with hard drives. He's already got a prototype running, and expect maybe 2015 or so and it might actually get to a spot where we no longer actually have a drive, that the case of our computer or something actually becomes where we're storing data. And it apparently does it without changing the state of an atom. It's the first time we'll have storage that doesn't change the state of an atom. But he's got a prototype built and working already. So, yeah. Well, that doesn't mean that they're not. It just means that nobody bought them. Right. Well, we're slowly working our way out of hardly any competition anymore at all. So, for instance, Toshiba and Fujitsu are now merged. It just happened. So now we only have Seagate, Western Digital, IBM, Hitachi / whatever, and Samsung, and then Toshiba and Fujitsu just merged. So Samsung's the worst of my choices, I would say, but they're easier to fix. Western Digitals are getting a little harder, and the head alignment problem. Seagate just went through all their firmware problems, so they're kind of cleaning things up, but they still have a couple other firmware problems. But I would still probably choose Seagate and Western Digital right now over the choices, just because I can fix most of the problems. So, yeah, I know it's kind of bad that, RAID 5. Whatever drive you use. Yeah, RAID 6. Yeah, go ahead. Yeah, a lot of power supply manufacturers are really cheap these days, and buying a cheap power supply, and there really is a difference in quality in power supplies. I'm telling you right now, buy the $150 power supply. It makes a tremendous difference in the whole operation of your machine. In addition to that, too, just the fact that you actually have a decent power supply, in some cases, actually will make the drive run better physically. You'll actually see situations where the drive will be underpowered and won't run appropriately and blow quite a bit, actually. Usually, you go by weight of a power supply. Whatever is the heaviest power supply, it's usually the best power supply. But, you know, I swap them all the time, just depending on whatever's the best one for the week. But buy the $150 versions. Stay in that range in the price. If it's not over $100, you're probably being ripped. So, yeah. You know, well, I mean, there's some older ones that are probably 100 pounds that might not do you much good, but. Well, you know, it's really ironic that that's what the purpose of the device, the software is, but you can't actually do that if you really think about it. Because the whole point would be you want to automate that process so that it can do its 24-hour run when you're not there, and there's no way of automating the process, right? It's a boot floppy, and you boot on it, and you do your job, and that's it. So it would be probably good to refresh sectors along the way. It's a great maintenance tool from that standpoint, and it's actually one of the only software tools that gives you feedback similar to what I'm expecting on hardware. And I have tried, and I have begged. I'm on radio shows, and I do podcasts, and I can not get Steve Gibson to listen to me at all, but, you know, whatever. He has a lot of information about hard drives that are wrong, too. If you listen to some of his podcasts, for some reason he thinks if you low-level format a hard drive, that it will wipe the SA area and you'll lose your passwords. So, you know, because you can set a password on a drive, and he said the low-level formatting has nothing to do with the SA area of the drive. You know, there. So, when your drive is going bad, really constant pauses and this constant, you end up with wait times. When you're trying to request files, you're trying to talk to your folders and stuff like that, all of a sudden you'll just hear, and you'll hear sometimes the drive recalibrate. You'll actually hear it go, and it'll go back to the beginning and start all over again if you can still hear your drive depending on where it's at. In a lot of cases, those start to be good warning signs. If it's starting to happen frequently, you could start watching some of the smart data and try to get a feedback, but at least from that standpoint, most of the time, the only real indication, now smart at least will track bad blocks and tell you how many you have. And if you see that number going up, then you know that might be a good indicator. But most of the bad blocks aren't detected on read times; they're detected on write times. When you have a read failure, it doesn't redo anything to the bad blocks or add it to the bad block table. In most cases, it'll just crap out, fail. Your machine will blue screen, something like that. So that'll be kind of the situation that you'll run into. So those are some of them. So, and then I had a couple others, like there are instructions on, and again, this is on my website. If you just go to my website, go to presentation page, go to PhreakNIC, you can download this, and these are some place you can go that'll tell you how to use DD Rescue to recover from a dead hard drive. So somebody else wrote that. This is a picture from what OnTrack says they recovered from the space shuttle, and that they, you saw that thing where after 5 years they've recovered data working on the drive for forever. Well, I have a real problem with this picture, and again, I don't know if it's true or not, or what they did. I've seen the other drive. There was 2 drives, and the other one was burnt to a crisp. They couldn't get anything from it. But this one bothers me. Anybody have a reason why this might bother you? There's a chip down here. Not only is there a chip, this chip was obviously desoldered from a board. It didn't just like melt and fall in there, right, inside the drive. So this looks like a setup to me for the picture. Just saying. So that was kind of my thing, is like it was desoldered from a, anyway. And here's some other, it's really hard to get data recovery information. These are actually the best sites, and 3 of these I do all of the material that's on them. HDD Guru is a terrific site, actually. It's a publicly accessible site. There is another one that's not publicly accessible that you have to pay a lot of money to get in. But HDDguru.com is a great site to go to for data recovery and talking about these things and trying to find parts and do stuff. But if you act like a newbie on there, they will beat you down. They will not help you at all. They'd be like, pack it up for $3,000, I'll do it, or something like that. But they won't give you any answers. But if you act like you're a professional, you know what you're talking about, and you use some terminology and shit that I do here, you'll actually be able to get some kind of answer, maybe. So anyway, so and then the other sites I actually have a lot of detail on this Google group site, and a lot of the other people that I do classes for, that when they find things out, they post it there. So there's things like the solid state disks and the resistor packs and things like that are on there that blow, and all kinds of stuff with LBA maps and how the MFT works and things. Those are all up there. So so it's a great site to go and read. And the firmware patches, you know the firmware patches from Seagate, that if you send it to a data recovery company, costs $2,000, $3,000 to do, they're posted on this site for free. You just go up there. All you got to do is buy that $25 cable that I listed at the beginning, and you can apply the firmware patches for free to a non-working drive. So all the code, all the stuff you need, and the boot disks are all up there. So, yes, sir. They have a lot of head problems, but their heads are actually easy to replace because they have a spindle that basically you can attach the head assembly to, and you don't have as much problem as placement as you do on like Western digital drives, and so they tend to be replaced easier. And there may be some questionable components with regards to how long their chips are baked or seasoned before they become, that's kind of the difference between like an Enterprise Edition drive too. So if you buy a Western Digital Enterprise Edition, typically the electronics are better, and that they've actually done a little bit more work to, help stability, but they're $100 more. So I would be looking at things like that from an electronic standpoint. So. Well, hard drives obviously don't like heat that much, and even though Google publishes a white paper that says that they don't like cold that much either, I would disagree with everything that Google said on that paper, almost completely. And I know that's a lot coming from it. It's like, oh, you're pretty bold, whatever. But, they kind of start out the paper by saying, hey, let's look at SMART data, and SMART is a complete failure, and we won't use it. And then they showed all these measurements that came from SMART or something for the drive and why it fails under cold conditions and things. But typically, to answer your question, I've seen drives running at 160, 170 degrees that are still functioning. They just don't typically, they're not great from that standpoint. I would prefer to see drives running somewhere in the 110 range. That would be the more common in a physically running drive. You can try to keep them at 70, but if your room is at 70, your drive's going to run at 110, probably. So, anybody? Yes? There's one freebie that's a Perl script. If you look at any of my previous stuff, the Perl script will actually let you lay out your own functions and do that. If you're running Linux and you want to redo, well, there is a Linux tool that is free, that is Windows, that will actually do the Linux stuff, but it won't reassemble RAID. RStudios is the cheapest for reassembling RAID arrays of almost any kind from that standpoint. RStudios, you can buy their $79 product, and it has a visual layout for doing that. And there is also a tool that will actually guess at all your sizes. So if you're doing Get Data Back has a tool that's called RAID Reconstructor, and you can put your drives in there, and it will actually try to determine the layout of the stuff. I've done a whole talk all on RAID, or several talks actually, all on RAID, and actually how to reconstruct them from porn and other stuff. And so if you go watch any, like I just did the DEF CON talk on all RAID, how to recover from porn and stuff, and then I did Outer Zone. If you guys went to Outer Zone, I did a RAID reconstruction. How to do it visually by actually using graphics on the drive to actually figure out what your slice sizes are. Because that's your hard part, is not knowing what your slice sizes are if you didn't set up the RAID array. Yeah. There's JPEGs are very difficult to reconstruct, and fragmentation on JPEGs is very difficult. But there's a couple of them. There's a tool that's called Android that is it tries to do fragmentation recovery and actually tries to do predictive recovery of the files. There's probably 2 or 3, but they started out as like scientific papers and gradually made their way into how do you deal with fragmentation. Well, there's a JPEG formula if you're actually doing them as JPEG, but if you're doing them as RAW, then there's a whole other formula. But that's why I said that the fragmentation stuff is actually the best formulas for doing that so far. Somebody has done both pictures, JPEGs, and has done MP3s. And there's an issue with the compression ratio and how the compression ratio, and that's the calculation they're actually doing. But RAW, the only way that you're going to deal with RAW files, because there's no compression, is to deal with the fragmentation itself. And so in most cases, you have to actually mount the file system, depending on what it was that was written to the disk. And most cameras, it's FAT. So it's FAT32, actually, most of them. So, yes, sir?
You're talking during your first stop here, when you were hooking up the serial connection to the drive, and it basically went into mode where it was checking every single bit on the drive, and it would return busy state. Is there a way that you could get maybe that program to not run because it sees something else taking precedence?
No, the way you fix that particular problem is you actually have to put the drive into what's called safe mode, which means I'm going to read content from the board, and I'm not going to pay attention to any requests. I'm just going to pause talking to the drive. You read all the code from the board and the drive, and then somebody actually wrote patches that load back into memory. So what ends up happening is you read this content from the drive, you save a file, then when the file is reloaded, it applies a patch, shoves it back into memory on the drive itself, and as long as power is still applied to the drive, it will continue to function at that point in time, turning off that function itself. But there's no way to write that back to the drive. The repair isn't written back to the drive. It'll continue to do that after it's powered off. But it's a combination of hardware and software that actually makes that happen, and it's about $15,000.
Well, I was saying that because on the little RCA cameras,
Yeah.
when they put the security features in to keep us from hacking those,
Yeah.
somebody found out that basically when it first comes on, if you change the password, it will change itself back. But during the point where it's changing itself back,
Yeah.
you can run a jumper wire onto one of the chips, and it sends a signal because the chip thinks it's doing something.
Yeah.
So basically, it thinks it's busy, and it never rewrites the password, and everything just ends up with 0.
Yeah, I mean, we do that a lot on IBM drives. The IBM drives have that similar kind of function. That's how we actually have to reset them. And we go through that process a lot, but that's not going to solve the Seagate problem with this particular thing. But there is pins on there, too, on the Seagate boards themselves that you can short so that they transmit the signal back and just put the drive into pause mode. But it doesn't solve the problem so you can read your data. You can talk to the SA area, but you can't talk to the data. You can't talk to user data. So that's the problem, is this CPU busy thing. But I know what you're talking about. I've seen it a couple times, and we trick them sometimes. Like if you actually write a password to a drive and we need to get the password off a drive, there are ways of doing a similar function like that to trick the drive into thinking that we're writing a new password and it clears the old password in return instead. So, yes, sir? Well, the first rounds that we had with these Western Digital drives with these new boards, a lot of us didn't understand them altogether because the problem with these fuses, we've not seen a problem with, usually if it was one fuse on the board, we could actually read the whole drive, or we could skip around and we'd be able to read content. And it actually took a little while for most people to actually recognize that the problem was a PCB board problem. And so I revisited some drives after it was found out and then was able to actually recover data from them. But initially, see, we're always like 6 months behind on whatever the current drive is that's released because somebody's got to actually buy them, have a problem, then develop the actual reverse engineering function of fixing those things, and then distribute them. So we're always 6 or 7 months behind on a problem. We still can't completely deal with the Seagate firmware problems. We can do some functions, but since Seagate changed their code completely in December of 2008, and their whole function, they actually used some stuff from their SCSI drives and stuff like that to actually change their functions. And we still can't do everything with all the 7200, 11, and 12 drives that are out now that we could do with Seagate drives prior to that. So we're kind of stuck in some things. Yeah. Oh, no, you don't get any cooperation from a drive manufacturer. They suck. They do. They will not tell you anything, and they're always worried about, being sued or whatever. I mean, like right now, Seagate's got a major problem with a particular firmware problem. Again, another firmware problem that they're not directly addressing, that they've changed some code that we've already repaired and fixed, and then we don't have a way of actually fixing it again, and it'll have to be reverse engineered again. But they're not fixing them under warranty and doing the same stuff before. So there's some things that are happening there that's like, oh, well, we have a data recovery company. Why don't you send it to our data recovery company? Because Seagate has their own data recovery company. Seagate has their own data recovery company. Is that not a conflict of interest? I don't know. So, but no, they are not helpful at all. You can't get any of that. As a matter of fact, that's one of the reasons why a lot of the data recovery equipment isn't even sold in the U.S. or you can't buy in the U.S. because all this code in the ROM and all the stuff that's been reverse engineered, they're trademarked, they're copyrighted, or whatever the hell. You can't reverse engineer stuff. So you've got to buy the stuff from China and Russia. Nothing's made in the U.S. None of it. Not a single thing. I can't hardly find anything made in the U.S. We have to buy it all from someplace else. So the closest manufacturer for most of this stuff is in Canada, but they sell the Russian stuff from Canada. So, any other questions? Nope. Yep. You mean it starts decrementing its sizes because it changes its block sizes as it basically shrinks them down as it goes, trying to do the repair on the sectors. But I mean, are you saying that that's all you got from the drive altogether? Oh yeah, no. As it starts with a larger block size, and it can shrink its block size as it goes. So it tries to do these. It's faster in UDMA mode to actually transfer chunks of data at one time, and transfers it across the bus and into the drive. And then as time as it gets worse, it goes back and it tries to shrink that size down, shifting basically the size of the block size till it reads smaller and smaller chunks before it actually transfers the data. So that's why it's decrementing its size as it goes till it gets down, only for speed purposes. Because you could set it to its lowest possible value and then read every single sector and then transfer the sector, but it would take you forever. On like a 1 terabyte drive, it might take you 2 months, 3 months to transfer the data. Buy hardware. Yep. Deep Spar Disk Imager will take care of that problem. Some of the problems that you can actually do, like a week for DD Rescue, might take 2 hours for a Deep Spar Disk Imager. A Deep Spar Disk Imager has one other function, like I mentioned earlier. It's the cheapest way to turn off a bad head. If you have one bad head, you can actually tell the system to turn off a bad head, read all the data from all the other platters, and still actually have a result that you can actually give back to the client or do whatever, and then fix the one head and fill back in the holes that you're missing. It actually has that function built in. It's the cheapest possible solution, and that's only come about this year. Before May, we couldn't do it at all, not with this. We'd have to spend $15,000. Deep Spar Disk Imager is about $3,000. Okay, done. Thanks.